All right, so I'm going to be proving this theorem by induction. So what it says is for any number greater than or equal to 4, 2 to the nth power is greater than or equal to 3 times n. So the first step is just to prove the base case, or like the first integer in this infinite set. So we're saying that 2 to the fourth power, which equals 16, is greater than 3 times 4, which is 12. So that's true. Um, the next thing we need to do here is create a inductive hypothesis where we assume that um, for any number k, this inequality is still true. So, and if that's true, then we'll take the inductive step of um, saying that 2k plus 1 is greater than or equal to 3 times k plus 1. And this kind of, we're going to be solving for this because it once we break it down enough, it'll show us that this is true for any integer greater than or equal to 4. So for this one, I'm just going to focus on the left-hand side of the inequality. So, and we're ultimately trying to like do kind of a like algebraic breaking down of this so that of this so that it equals that. Um, so 2 to the k power plus 1, we can also express this as 2 times 2 to the k power. Um, that's just simple algebra. And so now we can try to bring in something from our induction hypothesis. So over here, we can see that 2 to the k power is greater than or equal to 3k. So since we have 2k here, we can just substitute that in. We can substitute like a smaller or equal to term. So we'll say, and we'll note this by doing the smaller than or equal to. So going to replace that with 3k. Next, this really breaks out to 3k plus 3k. Um, and yeah, since we're trying to get to 3 times k plus 1, we want to make this even smaller, substitute maybe something for this. So since n is greater than or equal to 4, um, if we just take one of these k's away, we can say 3k plus 3 is less than or equal to this. So um, I just did that just because it allows us to factor out this problem up here, or this side of the inequality up here. So now you can say that's equal to 3 times k plus 1. And through this algebra and using the inductive hypothesis, it shows that this inequality is true for any integer, or 2 to the k power plus 1. Yeah, so that is that is it basically. Actually, I didn't do that right. All right, there we go. Yeah, um, that's just a inequality solved by induction.